Hello everyone and thank you for joining us today in our live webinar. My name is Kashif Meman and I am working at Royal Sabre as a delivery manager of managed services. I am your webinar speaker along with my colleague Kamran Siraj and Metrai Mishra, our HCL Commerce experts. If you have any questions or have trouble in hearing or viewing the webinar at any point in time, please let us know in the questions window. You can also post your questions or any comments in the same window anytime during the presentation. We have a dedicated slot to answer all your questions at the end of presentation. In today's session, we'll provide you technical insights and the guidance and perspective of using HCL Commerce version 9.1.10 with Elasticsearch. Starting with version 9.1, data platform microservices manage indexing and other crucial tasks with no performance impact on the storefront or transaction server. HCL Commerce Search uses Apache Lucene at the basis of its search framework, making integration with third-party applications an easier process. Both Solar Search and the new HCL Commerce Search solution powered by Elasticsearch are supported in HCL Commerce version 9.1. In one of our previous webinars, we have already covered deployment of HCL Commerce version 9.1 with Solar Search on OpenShift. And in this webinar, we'll cover deployment of HCL Commerce powered by Elasticsearch using Docker Compose. Before proceeding further with the technical discussion, I would like to share some overview about the Royal Sabre. Royal Sabre Incorporated is a globally recognized award-winning technology partner that is helping companies imagine, execute, and accelerate their digital transformation journey for the past 20 years. Royal Sabre provides superior solutions that create exceptional business value, guarantee success, and transform businesses with the robust and adaptable digital solutions that satisfy today's needs and unlock tomorrow's opportunities. This is our agenda, and we'll see about these in the today's session. Now, I would like to request Metrai to start with the technical deep dive about Elasticsearch and its services components.
Thank you, Kasif, for the introduction. Hi, everyone. So, before explaining HCL Commerce Search and its architecture, let's discuss what is Elasticsearch. Elasticsearch is a distributed and analytics engine. Elasticsearch provides near uh, real-time search and analytics not only for text but also for all types of data, including numerical, geospatial, structured, and unstructured. Elasticsearch stores and indexes data efficiently in a way that supports faster searches. Elasticsearch searches for indices instead of searching for text, which gives the result faster. Elasticsearch goes beyond simple data retrieval and aggregate information to discover trends and pattern in the data. Elasticsearch is also distributed in nature, which enables deployment to grow seamlessly as the data and query volume grows. The search capabilities of HCL Commerce Search are auto suggest menu for suggested keywords, categories, brands, site content, and search history. It also supports keyword suggestion, automatic search term suggestions, and spelling corrections. HCL Commerce Search also provides faceted navigation and allows you to create search rules and do search rule experiments. HCL Commerce Search also allows you to configure search term associations, search term highlighting, and wildcard searching. In this slide, we will discuss a few of the feature differences between HCL Commerce Search with Solar and HCL Commerce Search with Elasticsearch. In feature indexing, Solar supports full reindexing, partial and delta index update, whereas Elasticsearch supports full reindexing, real-time index update, extensible ingest pipeline, in-memory data flattening, transformation, and ingest pipeline monitoring dashboard. In feature of customization, at Solar is an open source. It has a lot of open source application components. With Elasticsearch, we get visual flow programming tool for ingestion, lightweight development tools, open source application components, loosely coupled search application architecture, and API based configuration. For search result ranking and uh, relevancy, Solar supports workspaces, tools to manage SEO URLs, search rules, search term associations, and creating web activities related to search in Management Center. Whereas HCL Commerce Search with Elasticsearch supports natural language processing, color matchmaker, dimension measurement uh, matchmaker, range filter, unit of measure filter, workspaces, tools to manage SEO URLs, search rules, search term association, and web activities related to search. In storefront experience, there is not much a difference. Uh, Solar search supports faceted search navigation, product variants, catalog filter, product entitlement, price rules, price mode, HCL Commerce Platform language support, language fallback, result regrouping, configurable auto support, auto suggest, and type ahead, search term highlighting, stop words, and sales catalog. With HCL Commerce with Elasticsearch, we get faceted navigation, product variants, catalog filter, product entitlement, price rules, HCL Commerce Platform language support, language fallback, HCL Commerce support for language, natural language, result grouping, configurable auto support or type ahead, search term highlighting, stop words, synonym text files, and sales catalogs. Just to point out, synonym text file is available with Elasticsearch. As shown in the slide, the HCL Commerce solution architecture is based on Elasticsearch, allowing more agility by separating components into individual servers and moving away from the old monolithic technologies. As you can see, each component has its own uh, container. Now, in as in such component interaction, as we can see in the image, HCL Commerce Search compromises of different components. We have Ingest Service, which is similar to pre-processing and build index in Solar. Then we have Query Service, which is similar to runtime process in Solar. We have Zookeeper, Radish, and Elasticsearch. Each of these components we will now discuss in detail. Ingest Service. So, Ingest Service prepares the data to be indexed in Elasticsearch through indexing pipelines. This runs on Apache Nifi, which is an ETL tool. As shown in the image, the data is loaded from various sources to in Ingest Service, which sends the data to Elasticsearch after processing. Now, there are different pipelines provided, which includes pipelines for store, catalog, attribute, category, product, SEO, price, inventory, entitlement, and merchandising. Another component is NIFI registry, which is used to store and manage multiple versions of indexing pipelines, which which are used in NIFI. The next service which we have is query service. Query service is for processing runtime queries, which are provided by the user. Now, query service compromises of multiple services. Query service prepares the search expression for Elasticsearch and provides REST API endpoints for storefront and query admin or configuration services. This query service exposes its REST endpoints. Query service consists of REST-enabled Java classes implemented as Spring Boot controller, which includes product view, category view, content view. It also has Spring Boot business services, which are singleton helpers for performing repetitive operations, search service that calls Elasticsearch, and configuration service that calls Zookeeper for the configurations. Elasticsearch all Elasticsearch provides a search engine service. Some of the highlights of Elasticsearch are search solution. This is a search solution which uses default Elasticsearch containerized distribution. It has enhanced multilingual support with over 30 built-in language-specific analyzers for text analysis, such as tokenization, stemming, and stop words. This also has dynamic index charts, which allows more node to be dynamically added and rebalance the data automatically across the cluster with zero downtime. This also supports hot swapping of newly built indices using index aliases. Reindexes has Reindexing has minimal impact on your live index cluster. Also, it supports faster incremental snapshots, which allows you to take backup at frequent intervals. This search solution fully supports multi-tier marketing and features near real-time updates. The next component in query service is Zookeeper, which provides service for managing query service configurations. The Zookeeper provides, as mentioned earlier, the Zookeeper provides following configuration service for managing customization and extensions. The query service configurations include custom search profiles, which supports inheritance and value override, runtime configurations for the component, query extension, and search term associations and stop words. For natural language processing, uh, filter and matchmaker configuration, which includes color, measurement and dimensions for a product, uh, range filter, and custom noun and classifications filter. Then it also includes part number pattern matching filter. This also has field weighting configuration for relevancy and ingest service connector descriptor. The next component which we have is Radish. Radish is a messaging bus which connects all these search service components and is also used for distributing change events as well as cache invalidation events. Now, I would like to invite Kamran to discuss a deployment with Elasticsearch using Docker Composer.
Thanks, Metoy, to provide us the great technical insights on Elasticsearch. In the next part, we will see HCL Commerce deployment version 9.1.10 with Elasticsearch using Docker Compose tool along with demo. So let's move on the concept of Docker. Docker is an open source platform that enables developers to build, deploy, run, update, and manage container standardized executable components that combine application source code with the operating system libraries and dependencies that will be required to run that code in any environment. Nowadays, containerization is increasingly popular because containers are flexible, lightweight, interchangeable, portable, and scalable. What are the major differences between Docker versus VMs? VMware emulates machine hardware, whereas Docker emulates the operating system in which your application runs. Docker is a much more lightweight virtualization technology since it doesn't have to emulate server hardware resources. When we talk about the virtual machine, so a software component called a hypervisor acts as an agent between the VM environment and the underlying hardware that provide the necessary layer of abstraction. VM that runs on the hypervisor is often called guest OS. Also, VM's operations are typically resource intensive. On the other side, when we look into Docker containers, so using a containerization engine such as Docker Engine containers creates several isolated OS environments within the same host kernel. Only bins, libraries, and other runtime components are developed or executed separately for each container, which makes them more resource efficient as compared to VMs. Docker architecture. Docker uses a client-server architecture. The Docker client talks to the Docker daemons, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same system, or you may connect a Docker client to a remote Docker daemon. Docker client and daemon communicate using REST API, and we have three main components of Docker architecture. First, we have Docker client. Docker client uses a commands and REST APIs to communicate with the Docker daemon. Second, we have Docker host. In Docker, the host is a machine that is responsible for running one or more containers. And at last, we have Docker registry. The registry is a stateless, highly scalable server-side application that stores and lets you distribute Docker images. The registry is in open source under the permissive Apache license. Docker Compose. Docker Compose is a tool that was developed to help define and share multi-container applications with Compose. We may create a YAML file to define the services and with a single command can spin everything up or tear it all down. Docker Compose allow us splitting our application into multiple containers that allow you to better isolate and maintain key services. Also, it provides a more modular and secure approach to application management. Now we have env.sh configuration file. After HCL Commerce version 9.1.6, all deployments configuration and environment configuration for the Docker Compose deployment method is made within the env.sh configuration script. The env.sh configuration script contains all deployment environment and configuration for the Docker Compose deployment method. It is recommended to maintain different copies of the environment file for each deployment configuration. For example, if we have auth environment, so we may create env.asset.auth. If we have live environment, then we may create env.asset.live. Similarly, if we are deploying data environment, so we may create env.asset.data for all live and data deployment respectively. This makes follow-up deployments and tear down significantly easier. env.sh configuration overview. In env.sh configuration, we have couple of sections. First, we have deployment section. This section defines the deployment configuration parameters that define the application that are included. First, we have deploy underscore type. This parameter controls whether the deployment is for HCL Commerce application or for the Elasticsearch based search solution data platform. Accepted values, we have commerce or data respectively. And then we have search engine that defines the search engine that is used by HCL Commerce. Accepted values are Solar or Elasticsearch. These values define the search infrastructure and search configuration for the deployment. This configuration and infrastructure also depends on the env underscore type parameter. Then we have another section is license section. License section is simply define the license acceptance requirement. So during the deployment, we need to make sure that license underscore accepted would be true, that is required for HCL Commerce to operate. Then we have common section. This section defines the HCL Commerce environment and server host information. Env type, these parameters define the HCL Commerce environment type for the deployment. The primary impact of this within deployment context is the database that is used, as well as how the such infrastructure is configured to be curated. Accepted values in env-type, we have auth for auth environment and live for a live environment. We may deploy authing environment to explore the full functionality of HCL Commerce, or both an authoring and live environment to explore and experiment with the non-production to production publishing capabilities that this advanced production deployment topology provides. And second, we have section database section. This section defines the database connection information that is used by the HCL Commerce deployment. Then we have some other sections like application sections. This section includes application specific configuration. Each Docker image and its tag can be defined within its corresponding application configuration section. Then we have integration section. This section includes integration specific configuration. For example, IBM MQ integration that is introduced in HCL Commerce version 9.1.10. Also, we have feature section. This section also include first time in 9.1.10 version, and this section include feature specific configuration, for example, marketplace features. env.asset topology. Here, we will see only those parameters that specifically dictate your deployment application and the resulting topology. Additional parameters such as licensing and database section are also required. Some configuration such as specific application configuration or those of your live database are only required when your deployment topology requires them. So let's move on HCL Commerce deployment topology. To deploy the HCL Commerce applications, the following env.asset configuration parameters are required. We need to make sure deploy underscore type parameter is specified as commerce. This will deploy the commerce application for the corresponding search configuration and environment type that is specified. Then we have Elasticsearch based search deployment topology. To deploy the Elasticsearch based search solution data platform, the following env.sh configuration is required. Here also we need to make sure the deploy underscore type parameter is specified as data. This will deploy that data platform. The search engine parameter is still required to be set to Elasticsearch by the deployment script. Before to proceed with the HCL Commerce deployment version 9.1.10 with Elasticsearch, we have some prerequisites that should be in place and running. First, we have Docker. Docker version 19.03.8 or later should be installed. Second, we have Docker Compose. It also be installed and set up in our environment before the deployment. And at last, we have database, Oracle or DB2 should be running. So in our session, we will be using DB2. After complete all the prerequisites, then we needed to download the desired HCL Commerce Docker images for version 9.1.10 along with such service components, images like ingest, Nifi, Nifi registry, query, and respective DevOps bundle to get env.sh configuration file and a deployment script. After download all the desired packages and images from the HCL portal, then we may proceed with the deployment steps for HCL Commerce with Elasticsearch. So let's review these steps. As we see, first we need to download all the desired packages from the HCL portal. Then we may need to load all these images into the Docker registry. Then we need to extract the DevOps bundle. This DevOps bundle we will provide env.asset configuration file and deployment script for Docker Compose. Due to the high resource requirement for the Elasticsearch based search solution, it has been separated into its own separate deployment. These features of the Aura Docker deployment process allow for you to manage your compute resources and to account for performance requirement or resource limitation by allowing for multiple machines or virtual machine to host different parts of the Aura deployments. Because of this separation, if we are deploying HCL Commerce with the Elasticsearch based search solution, then we may need to update and modify env.sh file two times. First, we may need to update and modify env.sh file according to environment variables and deployment parameters that will be reflected for Elasticsearch environment. And we need to rename this file like env.sh.elastic. Then we may need to update and modify env.sh file second time according to environment variables and deployment parameters that will be reflecting HCL Commerce application environment. And also here we need to rename this file like env.sh.com. Then we may need to execute the script twice, once for the HCL Commerce application and second time for the Elasticsearch based search data platform with the help of env.sh file that we created in the previous steps for both the environments. Elastic and Commerce. But before deployment, we need to make sure, let's suppose if we want to first deploy Elastic Stack, so we need to rename env.sh.elastic to env.sh, and then we may need to execute deploy.sh script. So this script will pick all the changes that will specified in env.sh.elastic. So before the deployment, we need to make sure that we will rename the files again into env.sh from env.sh.com or env.sh.elastic. So after successfully deployment, we need to building the Elasticsearch index. In HCL Commerce version 9.1, provide us REST call using curl or postman for building index. So here we have a curl command that we may use to building the Elasticsearch index. When we deploy the HCL Commerce version 9.1.10 with Elasticsearch, so we will get 4 stores: Aurora eSite, Aurora B2B, Emerald, and Sapphire. And the store IDs would be 1 for Aurora, Aurora B2B 2. Similarly, we have 1 for Emerald store, and Sapphire would be 1 2. So we may use the respective store IDs for building the Elasticsearch index. Once we successfully deploy the HCL Commerce version 9.1.10 Elasticsearch, then we may interact with each of the services and the URLs. And here, after deployment, we may get 2 new stores, Sapphire and Emeralds. So now it's time to move on the demo. So this is a demo machine that we created with the HCL Commerce version 9.1.10 with Elasticsearch. So here you can see that we download and loaded all the desired images. That's for SL Commerce, data application, and the third-party tools like Zookeeper, Redis, and Elasticsearch. After that, we have DevOps packages, and as we see in the slides, DevOps bundle will provide us env.sh file, and also it will provide us deployment script deploy.sh. Also, we will get env.sh configuration file. So uh, let me open this file for you. So I will show you the some parameters. Okay, so here you can see now we have different parameters that depends on which stack we are going to deploy, either Elasticsearch, either SL Commerce. So we need to update all the values that we already discussed in the previous slides, env.sh configurations and topology. So that's same thing we need to follow here, and we need to update these files accordingly as per our environment needs. So here we have also database information. Here you can see now I'm using DB2, and these are DB2 host. And similarly, we have these all the DB2 credentials, ports, and all the information that we needed for the SL Commerce deployment. So this file we need to update as per environment. And let's suppose if I want to first deploy Elastic Stack, so just we need to create env.sh.elastic. But before, as we discussed in the slides, before to deploy, first I need to rename this env.sh.elastic to env.sh file, and then uh, we can run deploy.sh script. This script will bring the deployment online, and also it will deploy the desired stack, either Elasticsearch or HCL Commerce. Once our script will be completed, then we can see here all the containers will be up and in healthy. Here you can see we have all the HCL Commerce containers along with search service components like we have search query, ingest, Nifi query, along with third-party tools like Redis, Zookeeper, and Elasticsearch. So we need to make sure after deploy, we have a container with healthy status. Once all the containers would be up and healthy, then we may interact with the HCL Commerce services and store that I show you in the previous slides. When we deploy HCL Commerce version 9.1.10 with Elasticsearch, so we got 4 stores: Aurora B2B, Aurora B2C, Sapphire, and Imal. That's 2 new stores that comes with Elasticsearch. So let's move on Imal store, where I will show how National Language Processing NLP features that comes in version 9.1 with Elasticsearch makes such capability advanced, flexible, uh, with rangefinder and the matchmaker. So let's move on the Imal store. Okay, so this is our Imal store, and um, shopper often want to find the products with particular price ranges. So in this condition, the NLP processor is even more flexible. So let's suppose if I find if I want to find some products with specific ranges. Let's suppose if I want to like that show me a sofa less than 700. So now it will show all the products of the sofa, but the amount which will be less than 700. So it will show all the products. So that is the beauty of the NLP features in 9.1.10 with Elasticsearch. Similarly, if I want to find products less than 500, so we will get the respective result. So here you can see now I found one product, its price would be less than 500. So that is the we can say that it's really allow us to take those natural language filters and drive through the searching with most relevant search results with NLP. Then we have second matchmaker. The core NLP system has also been extended with matchmaker. There are 2 kinds of matchmaker at present, a color matchmaker, and second we have measurement or dimension matchmaker. Let's suppose if I want to find tables with 90 pounds weight. So in a search bar, I can type like find the 90 lbs table. So now here you can see, now we got the desired result, and here all the tables that weights 90 pounds we are able to see. So that is the beauty of the matchmaker. So instead of 90 pounds, let's suppose if I type 45 kg. So here you can see now I'm getting the same result. So it means that um, when we type the kg in filter, so matchmaker automatically converts kg into pounds and show the respective results. That is an other features of the matchmaker in version 9.1 with Elasticsearch. So also we have uh, let's suppose if I want to find any product, but in a desired color. So let's suppose if I type find a chair in color silver. Okay, so here you can see now I got 9 products. So matchmaker will look into the range of all the colors that will be available and will provide the complete range. And matchmaker also look the closest color within the silver, like light gray also next to the silver color. So it will provide a complete range of the colors and will provide the results as per our requirement. So that's flexibility we have with the SL search, and that is capability result on top of Elasticsearch that is committed in 9.1. And here also we have color option. Let's suppose if I want to choose any color that I want to check. Let's suppose if I click here, so I can take a look in the respective color that I just selected. So that is all the beauty in MR store that uses NLP, natural language processing, and we can easily use this language in a search bar to find the desired results with matchmaker and the rangefinder. So I think I am done.
Thank you, Kamran and Metrai, for the presentation. Our question answer window is open and you may post your questions or any comments in the same window. Thank you.